today's lesson, section 2.1b, we're still talking about what a function is. This one will be mainly kind of figuring out the domain of each function. Also, we'll be talking about piecewise function. So, to define a piecewise function is a function which is defined by multiple subfunctions. Okay, so basically two or more functions put together, and each of these subfunctions is applied to only a certain interval of the main function's domain. Okay, so each of these functions has a certain area or x's applied to it that it covers. So it doesn't, like one function does not cover the entire graph. It'll go to a certain point, stop, and then a new function will begin, and maybe it'll continue on forever, or it'll stop at a certain point and another function will continue in its place. Okay, so like here, for example 4, we want to evaluate the following piecewise function at the given values. So here, if you have the function of x squared, where x is less than 0. So for all the values that x is less than 0, x squared is the function that is over that domain. Okay, and give you a picture of that. Let's just draw that graph here. Okay, so here's your x, here's your f of x. Okay, so this is where x equals 0, right? So it says where it's less than, it's x squared. So x squared would be like your graph like this, where it would shoot up and go that way. But also notice that at x is less than 0 it does not include that. So like for an inequality graph, we would draw an open circle, okay? And at where it equals x is greater than or equal to 0, your graph or your function is x plus 1. So like here, you would get that function. So notice how they're kind of where, as we're going this way, from left to right, you have the graph of the parabola, and then once it hits the 0 mark for the x's, then a new function takes over. So that's kind of what a piecewise function looks like. So to evaluate that, we need to identify where the x values lie in the intervals, and then we use the correct function in that domain to help us apply or plug in our value into the correct function. So like if it's -2, then that's less than 0, so that would be this one. So then that means that I would do -2 squared, so that gives me 4. Okay. Okay. Notice that this one's 0. Okay. Now this is the turning point for both, but for it to be on that line, it needs to be included, so it needs an inclusion sign. So the bottom one, x plus 1, has greater than or equal to 0. So then that's where we'll plug in 0 is into the x plus 1 function. So 0 plus 1 gives me 1. Okay? And then 2 is greater than 0. So if it's into this one again, so then now I do 2 plus 1 gives me 3. Okay? So that's the basics of evaluating using a piecewise function. Okay, so example 5 wants us to be able to find the domain of each function. Now, to be able to determine the domain of a function, there's several different things you need to look for. Okay, what usually restricts a domain is if they tell you a domain, like a restriction to begin with. So if they say, oh, it's x, where this is where only x greater than 2 kind of happens. So that'll restrict your domain. But this one's not that case. Okay? So you don't have to worry about that, but make sure you take notice if there are like inequalities attached to your functions. Also, make sure you're looking at your domain, because certain values of x will create it to be, or make it be 0. And remember, in the denominator, you cannot have 0 down there. Okay, so make sure you realize that that is a possibility, because that'll create an undefined function. So that kind of makes your domain restricted. And also, if you have variables in radicals, okay, remember that if I have a radical like this, that because it's a square root, you can't have negative values in your square root, because that creates imaginary numbers. So make sure you look at those type of restrictions to help you determine your domain. Make sure to put all your domain in interval notation when we're doing this, okay? So here, now letter A has a function of f of x equals 1 over negative 2x squared plus 2. Now, in the numerator, there's nothing there. It's just a 1, so that doesn't really do anything for us. Our domain does have an x value in it, so we need to determine what makes it 0, so that we can determine where our restrictions would be. So you can always solve the denominator for as set equal to 0 to help you find those values. So if I subtract 2 to both sides, 5 by negative 2, okay, so then here, because I'm square rooting, remember that the square root of plus, because it's plus or minus, because you get both, so plus minus 1 is possible, okay? So our domain would be restricted as such. So we would have all other values are fine. So just 1 and negative 1 make the denominator 0. So I could say negative infinity to negative 1 is okay. I'm not going to include it, so that's why I'm putting a parenthesis there. I can also go from negative 1 to 1, because all of those values are okay. And then, oh, and I forgot, when you're doing multiple inequalities, remember that you want to have your union signs, because they're like the union of all of these intervals. So negative 1, 1, and then also the interval from 1 to infinity. Okay, so that would be an answer for letter A. Okay, let's look at letter B. So you have the square root of 4 minus x. So we got to figure out where values are going to be okay and not okay. So if I plug in, let's start with, I always like to start with where 0 would be, because that's the smallest, it's going to be the smallest number you can plug in into a radical, like the overall radical, and still be okay, because that just gives you 0. Anything less than 0 will always be a negative number, right? So if you set your radical, or what's underneath your radical, equal to 0, to find that first value, then you can figure out which way you're supposed to go. Okay, so here if I have 4 minus x equals 0, I could add x to both sides. That gets me 4 equals x. So 4 must be the smallest value, or biggest value in this case, because if I plug in 3 into there, it makes it okay, because 4 minus 3 is 1. But if I went bigger, if I plugged in like 5, 4 minus 5 would give me negative 1. So in this case, it's kind of, because it's written backwards, because your x has the negative sign and not the 4, then that's how it kind of switches. So in this case, 4 is the biggest number that your domain can be. Okay, because everything else you plug in bigger will give you negative values for the radical, which would be smaller in essence to 0. Okay, that's kind of backwards, but so here, so since 4 is the biggest, we put it on the right side, so then that means the smallest has to be negative infinity. Now for radicals, it can be 0, so I can include the 4 in my domain. It's okay to have 4 go in there. So then that would be my domain, is parenthesis, negative infinity, comma, 4, bracket. Okay, now here, letter C, sometimes you have multiple variables. Now sometimes the variable in the numerator won't do anything for you, or do anything to the domain, because if it was just x, it would be all reals, from negative infinity to infinity. So it's okay. So we don't have to concern ourselves with the x in the numerator. The denominator has the square root of x plus 2. Okay, now here you have a combination of a radical and the radical being in the denominator. So still you want to find where it's equal to 0, like you have been. So subtract 2. Okay, so it would be x equals negative 2. This means that that's the smallest number for it, because if I plugged in negative 1, I would get a positive 1. And if I plugged in a negative 3, it would give me a imaginary number. But also, because it's the radicals in the denominator, I can't include that value in my domain. Okay, so we said that negative 2 is smallest, infinity is the biggest, and like I said, because that radical is in the denominator, I can't include the negative 2 in my value, so I need to put a parenthesis as well for that. Okay? And that's it for section 2.1. Have fun.